The next part of this video is the process of gene cloning. The first step is isolation of DNA gene of interest fragments to be cloned. For this step, we need plasmid. Plasmid is a small circular DNA molecule that can replicate independently of the chromosomal DNA in bacteria. In cloning, the plasmid molecules can be used to provide a vehicle in which to insert a desired DNA fragment. We also need foreign DNA. Both foreign DNA and a plasmid are cut with the same restriction enzyme. The restriction site occurs only once in the plasmid in the middle of the gene for an enzyme. The second step is the insertion of foreign DNA fragment into plasmid. The restriction enzyme leaves complementary sticky ends on the foreign DNA fragment and the plasmid, as can be seen in the diagram. The function of restriction enzyme is to recognize specific DNA sequences and cut them in a predictable manner. They are naturally produced by bacteria as a defense mechanism against foreign DNA. The foreign DNA will be inserted into the plasmid when the sticky ends anneal. Adding DNA ligase reattaches the DNA backbones. These are called recombinant plasmids. DNA ligase will permanently join the DNA fragments when the sticky ends come together. However, recombinant plasmids are DNA fragments that were inserted into a plasmid vector. The third step is combination of plasmid with culture of living bacteria. The diagram shown is when plasmids are combined with culture of living bacteria. Many of the bacteria do not take up plasmids into their cells, but many take plasmids that do not have the foreign DNA in them, but only a few take up the recombinant plasmids. However, the bacteria that take up the recombinant plasmid cannot make the enzyme from the gene that the fragment was inserted into lac-Z. They also carry a gene for resistance to the antibiotic ampicillin, which was on the original plasmid.